So hello there guys, my group and I are here to educate you about Isaac Newton and his three laws of motion. Since we are in a pandemic situation and can't go outside to give you this information, we are still here to do it by using the help of social media. I hope this video could help all of you and gain knowledge by watching it, even we are not seeing each other. Isaac Newton, with the full name of Sir Isaac Newton, was born on January 4, 1643 at Woolsthorpe Manor House in the United Kingdom and died on March 31, 1727 at the age of 84. Newton worked as a mathematician, physicist, and astronomer, and he is still known as a scientist who contributed to our understanding of the universe through his findings, which were the foundation of many scientific concepts. In optics, his discovery of white light's composition integrated color effects into the study of light and laid the foundation for modern physical optics. In mechanics, his three laws of motion, which are the foundation of modern physics, led to the formulation of the law of universal gravitation. In mathematics, he was the first to discover the infinitesimal calculus, one of the most significant single work in the history of modern science was Newton's Philosophiae Naturalis Principia Mathematica, or in English, Mathematical Principle of Natural Philosophy. He has a lot of great works during his career, but we will be focusing on his three laws of motion that help our rational worldview. So let's get started.
Newton's three laws of motion.
First law of motion. An object as at rest will remain at rest, and an object at motion will remain at motion unless acted upon by an outside force. Also called as law of inertia. Inertia, the tendency of an object to stay at rest or continue in an existing state. The ball will not move unless a force will cause it to move. If a ball was rolling on the surface, it will keep moving unless met with an outside force. When a car brakes quickly, the passenger will be thrown forward because inertia, the tendency to remain unchanged, tries to keep the passenger moving. A moving object does not stop moving by itself. A person riding a bicycle along a leveled road, if stops pedaling, does not come to rest immediately. The bicycle continues to move forward due to inertia. A small coin is put on a card and placed over the mouth of a glass. When the card is flicked away with the finger horizontally, the coin drops neatly into the glass due to inertia.
Imagine you're practicing for your 100 meters race on this track, and somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. It means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced. In the next video, we will look at a few applications of the first law of motion.
Second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. Also known as law of force and acceleration. Describes what will happen to a massive body when it is acted upon by an external force.
Determine the accelerations that result when a 12N net force is applied to a 3 kg object and then to a 6 kg object. Solution. For 3 kg object. Given, mass equals 3 kg, force equals 12N, acceleration is missing. Formula. F equals ma. Since we are looking for acceleration, divide both sides by m, mass, then, it will be A equals F over ma equals 12N over 3 kg. A equals 4 meters over s squared. A 3 kg object experiences an acceleration of 4 meters over s squared. Determine the accelerations that result when a 12N net force is applied to a 3 kg object and then to a 6 kg object. Solution. For 6 kg object. Given, mass equals 6 kg, force equals 12N, acceleration is missing. Formula. F equals ma. Since we are looking for acceleration, divide both sides by m, mass, then, it will be A equals F over ma equals 12N over 6 kg. A equals 2 meters over s squared. A 6 kg object experiences an acceleration of 2 meters over s squared. Suppose that a sled is accelerating at a rate of 2 meters over s2. If the net force is tripled and the mass is halved, then what is the new acceleration of the sled? Solution. Given, acceleration equals 2 meters over s squared. Since the net force is tripled, then it will be 3f. Since the mass is halved, then it will be 1 over 2 meters. Formula. F equals ma. Get the first equation. Since we are looking for new acceleration, divide both sides by m, mass, then it will be A equals F over m. 2 meters over s squared equals F over m. First equation. Apply the given. 3f equals 1 over 2 meters, Divide both sides by 1 over 2 meters, then it will be A equals 6 F over m. The value of F over m is 2 meters over s squared. From the first equation, A equals 2 meters over s squared, A equals 12 meters over s squared. The original value of 2 meters over s squared, acceleration, must be multiplied by 3, tripled force, and divided by 1 over 2, halved mass. Therefore, the new acceleration of the sled is 12 meters over s squared.
It will be very easy. Mathematically, it can be written like this. In simple terms, the acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. That's the second law. Or as more people understand it, like this. The net force is the product of mass and acceleration. With this, can you tell me the units of force? That should be easy. The standard unit of mass is kilograms, and that of acceleration is meters per second squared. So the unit of force is kilograms times meters per second squared. And this is what we call as Newton. 1 Newton is 1 kilogram times meters per second squared. So if the mass of the object is 10 kilograms and the acceleration is 10 meters per second squared, then the force will equal 100 newtons. We can say that 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second squared.
Third law of motion. States that for every action, there is an equal and opposite reaction. This can be observed both in objects at rest and those that are accelerating. Also known as law of interaction. Action-reaction. For every action force, there exists a reaction force that is equal in magnitude, strength, but opposite in direction. Sea creatures swimming actively. A fish uses its fins to push backwards. In return, the water reacts by pushing the fish forwards, propelling the fish through the water. Flying gracefully through the air. Wings pushes air downwards. In return, the air reacts by pushing the bird upwards.
Sitting on a chair. Consider sitting on a chair. Your body exerts a downward force on the chair. In return, the chair exerts an upward force on your body.
What happens when you place an object on the table? The object exerts a force on the table and the subject exerts an upward force on the object.
Sitting on a chair.
There are two forces
Consider
that
sitting on a
result from
chair.
this interaction.
Your body exerts a downward force on the
table
chair.
and a force
In
on the
return,
object.
the chair exerts
The
an upward
magnitudes of the
force on
two
your
forces
body.
are the same, but the directions are opposite. These forces are called as action and reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. What we saw here is nothing but a display of the Newton's third law of motion. Every action has an equal and opposite reaction. That's how simple the third law is. Every action has an equal and opposite reaction. It means that when two objects interact, there is a force on each object. The magnitude of force on the first object equals the magnitude of force on the second one. And what about the direction? The direction of force on the first object is opposite to the direction of force on the second one.